it is very good question. Why we choose UgCS and why we became a UgCS reseller and finally we reach premium reseller status right now. And I think, to tell the truth, we didn't like to be a reseller of UgCS, and we just search through the market to find out any solution to use drone for survey. And before, when we start our business, we tried a lot of softwares like Lychee, like all other softwares, and we found out that it is not possible to use for survey and mapping in a difficult terrain areas, in the areas where there is no internet, where you couldn't download, where you couldn't reach internet connection. And finally, when we come deeper and deeper to survey, we found out that all other software just provide you basic functions and basic features to make survey. But when you need to get a good, when you need to reach a good level of survey product, like three-dimensional model, or when you need to arrange mapping with LiDAR, you need a special software which allows you to tune up all your settings in a good way. And my first experience with UgCS, I found out that it was very, very complicated. And this is why we decided to take part in this event, to share our experience and to show all other surveyors that UgCS is very simple to use. You just need to understand the total workflow, and after that you can tune up your flight mission. You can set up your flight mission easily. And of course, as soon as a lot of our users use UgCS for mapping and surveying, they ask a lot of questions. And I try to sum up all these questions, and I would like to show you some tips and tricks how to use UgCS for real work in a very rugged conditions. And let me add some information about Evgeny. Evgeny, he's from Luki University, Finnish Research Institute, and they fly in very difficult conditions at night, in a polar night in a polar night in the winter and so on. And I think Evgeny will share his experience how to fly on very low altitude as soon as I understand from his topic. Evgeny, hello.
Hello, and nice to hear you. So I crashed several drones, and then I thought with Pix4dim, with other applications like Map Pilot, etc. And then I realized, okay, for example, you could have a Mavic Pro updated with TOPODRONE solution, and there are very nice sensors in Mavic, but those sensors simply doesn't work in forest condition. So I've got immediately the idea, okay, I need something else than just rely on sensors. I really had a case where I crashed a drone because it was 3 trees and drone was not able to choose to which direction to fly. So then it made a decision and crashed. So sensors are nice, but for me, UgCS is something else, some kind of like backup, just in case if your drone will not follow the sensors.
Okay, so let me start my presentation, and if you have any question, you are welcome to write this question, or just if somebody from our team or Evgeny, Sabine, or any guys from UgCS team will have any questions or any advices for me, I will be glad to answer it in real time. I think it will help us to make a real life presentation, and it will help us to provide more information for users. Okay, let's start. I will share my screen, and let me, I don't know if I have prepared presentation, but
yes,
okay.
just a small tip for our listeners. So in the background, we have also a UgCS team from support, and also Alexei Dobrovolsky is joining today. So please, yes, write your questions and write your ideas how UgCS has to be improved for LiDAR, etc., so we can discuss it and add this to our roadmap. Okay, Maxim, the floor is yours.
Okay, thank you. And I would like to start with this slide. It's just picture which we would like to prepare for to be like a premium list of our presentation, where we show our latest products. It's a LiDAR. And right now we produce very high precision LiDAR systems, which can be installed on Matrix 200, Matrix 300. And finally, we will reach this topic. But I would like to start from the beginning, from the point when we start our business, when we change our field of work. Before we were surveyors, just make some measurement with the equipment like total station, like GPS. But finally, we had to find any solution to make survey in the mountains and don't lay ground control points. And when we start our business with the drones, there were only few solutions at the market. It was very expensive survey drones starting from $20,000 or $30,000, and it was DJI RTK system installed on Matrix 600. And my business started when I bought Matrix 600 drone. Do you remember a huge one drone with 6 propellers, 6 motors, and it can carry heavy camera? But and DJI announced that it is real RTK system, and I just received a huge work for 10 square kilometers survey in the mountain area, and I went to Hong Kong to buy a Matrix 600 with RTK system. And after that, I had never tested this drone at work. I just bought it, and I just believe to advertisement that it works in real RTK mode. But finally, when I reached the place, it was 4,000 kilometers from Moscow, 1,000 kilometers from the airport. And I start to work with try to work with system. I found out that DJI RTK didn't work at all. It just allows to fly carefully, precisely, but it didn't save any precise coordinates of the images. As a result, I have to spend a few weeks more climbing in the mountains to measure some ground control points. And then finally, I understood that I just lost money with this equipment. And unfortunately, not unfortunately, it was like a big push to us, for me, to invent something which allows me to walk without any ground control points, without climbing, without special equipment to climb on mountains. And before, from my experience, I used to process satellite data. I used to make photogrammetry processing of satellite data, and I understood the total photogrammetry technology. After that, I moved to survey, and I understood GNSS data, post-processing, and everything. And finally, we found out a way with my friend and partner how to upgrade Phantom 4 Pro with additional GNSS receiver installed. It was one frequency L1 GNSS receiver from MLead, and guys from MLead, I think they changed the market at all, because they produce something which can be installed on the drone with a very small factor, and it provides very good accuracy. And when we made a first test, we achieved accuracy between 10 or 15 centimeters from the flight without any ground control points. And after that, we understood that this thing would help us to survey, to save our time, and now we don't need to go to the field to lay ground control points, so on and so on. And we start our business, and from the first request and after that, I share some information on the website and so on. And finally, we received a lot of requests to upgrade their drones. And after that, DJI announced Phantom for RTK. It was announced after 1 year when we invented the system, PPK system. But why we were focused on DJI? Because DJI produce very good drones, high quality drones. It's easy to fly. And after that, we decided that we can provide some equipment which can be affordable for users, which can be installed on their existing drones, and which provides which and this equipment should provide high accuracy. And first of all, we created 2-frequency GNSS receiver for the drone. After that, we installed GNSS receiver on Mavic 2 Pro, and you know that Mavic 2 Pro has very good Hasselblad camera, but unfortunately, Hasselblad camera has a rolling shutter. And after that, we started to work with Pix3D, and we found out the way how to remove rolling shutter distortion, how to create precise 3-dimensional models in orthophoto with using of Hasselblad camera. And after that, Pix3D approved our data processing workflow. And now data processing workflow, which is included in our data sets and which is included in our tutorials, this workflow was approved by Pix3D as well. And as a result, we become a premium reseller of Pix3D. And finally, what we faced and what problem we faced before we use some simple software like MapPilot, like Ground Station Pro. But as soon as we went deeper to the survey and we need to make survey in the mountains, in the hard to reach areas without any connection, we started to search for the market and we found out UgCS. And of course, UgCS is very difficult to understand from a first sight, because it's not a just a consumer application which can be installed only on a laptop or only on a tablet, on phone, and just one button to fly. But when you fly with one button, you shouldn't understand that you should understand that you don't receive high quality flying. You don't receive this software doesn't provide a lot of functions for flying to tune up road and so on. So right now we provide equipment for high precision survey which can be installed on any drone from Mavic Mini, and I think it's a very good solution. And this solution, due to the rolling shutter camera, but with a stable focal length, this solution provides 3 and 5 centimeter accuracy without using of any ground control points. And it can be easily processed in Pix3D. And during our seminars, we show how to use Mavic Mini for survey. And of course, we provide the PPK solution for Mavic 2 Pro, for Phantom, for Matrix. And finally, we designed, and of course, we wanted to use LiDAR in our survey. And LiDAR costs a lot of money, starting from $100,000. And finally, we design our own LiDAR system, which provides 3-5 centimeter accuracy and can be easily installed on any DJI drone and can be combined with a camera to get a colorized point cloud. And all these steps, how to survey with the UgCS, I will show during my presentation. So what we should know, that in order to make a precise survey, you should plan mission precisely. And on your equipment, you should use special GNSS receiver, which is built in a drone or additionally installed, or you should use additional sensors. And if we are talking about LiDAR system, comparison between LiDAR system and photogrammetry, I would say that photogrammetry is the most affordable solution to get 3-dimensional model. But photogrammetry depends on a lot of settings of flying. For example, on fly altitude, on light conditions, on overlapping, and all these things influence to final accuracy and to final quality of 3-dimensional. As a result, in order to get very good accuracy, to reach good accuracy of 3-dimensional model or map, you should use appropriate tool to plan mission, to set up the camera, to provide, to choose flight speed, and so on. If we are talking about LiDAR, LiDAR provides very stable results, and it doesn't depend on any lighting condition. You can fly at night, you can fly in a low temperature, but what you should provide, you should create a very smooth trajectory, and you should follow the terrain. And as a result, and you need to make IMU calibration during the flight. And all these features, all these functions are available in UgCS software as well. And if we talk about total workflow, data processing workflow, drone survey workflow, first of all, of course, we should install a base station or use your country survey network just to download Trinec file or to connect to this network. The next step, you should prepare a mission and you should make an aerial survey. And this is why it is very important to have stable software which allows you to plan mission carefully. And in this case, we will talk about it later. And all my presentation will be focused on mission planning for different type of applications, such as mapping, three-dimensional mapping, LiDAR survey, and so on. But of course, after survey, you need to post-process data. And in this case, right now, there are two different ways how to you get precise position of the photos in order to get very precise images. This one way, it's RTK system, real RTK system, real-time kinematic system, or post-processing kinematic. And if we are talking about RTK system, it's not possible to use RTK in the mountains, in the cities where you fly around buildings and you can lose your connection to the drone. As soon as you lose connection to the drone, between your drone and base station, you will lose precise position of the drone. And in this case, your survey will be spoiled. But with PPK, PPK provides you a possibility to be independent from any network. You just need to install your base station. As a base station, you can use any GNSS receiver which stores Trinec files in a static mode, and you should fly. And GNSS receiver installed on the drone will save kinematic dataset, raw kinematic dataset, and after post-processing, and you will get very precise position of the photo, which can be used in any software for photogrammetry processing. But what I would say that with post-processing kinematic techniques, you can implement additional filters and you can increase the accuracy of GNSS data post-processing in comparison with RTK. As a result, when you make survey in any area where there is no any internet connection, where there is no any GNSS receivers close to you, and you fly in mountains areas where you can easily lose connection to the drone, I would suggest to use PPK system. And for your flights with PPK system, you will achieve better accuracy in comparison with RTK. And what is very important for efficiency, that with PPK, you can fly much faster in comparison with RTK. What else? And of course, you need to check the accuracy, you need to play some ground control points. But with PPK system, you just need to put one or two ground control points to check accuracy, and maybe you need some ground control points to calibrate focal lengths. During our training, we show how to calibrate focal lengths, how to process data set in order to achieve accuracy between 3 and 5 centimeters. For three-dimensional models, we can, in some cases, we can achieve accuracy up to 2 centimeters. And of course, data processing, the longest part of data processing, it is generating of three-dimensional model. It's generating of three-dimensional point cloud. If we compare photogrammetry and LiDAR survey, I would say that LiDAR survey provides you more stable results, and you will receive dataset within 20 or 30 minutes after the flight. So in case of photogrammetry, you will get three-dimensional model after few hours or 10 hours, and if you have a huge project, you will get it within several days. But with LiDAR, you will get three-dimensional point cloud, which can penetrate high grass or forest, and you will get this point cloud within 20 or 30 minutes after flight. So when we make a survey, usually we have two people in the team. One guy is looking for the drone, and another one guy is processing data set. So during field work, we already process all data set. And let's talk about mission planning software. And why before we have a lot of requirements to get appropriate software for our survey. And as far as we had difficult projects to accomplish, to work in the mountains area, like I said, or hard to reach area without GSM connection, we created some requirements for mission planning software. First of all, as soon as we produce equipment for different type of drones, from Mavic Mini to Matrix 300, or for any other drones like Vito, we need one software which supports all kinds of drone. And of course, we need terrain following mode. And in some cases, when we make survey in the quarries or in some open pit in the mining areas, we need to add our custom terrain model for mission planning. And it's very important to fly on a appropriate altitude during the survey, as well as for photogrammetry and as well as for LiDAR. And what else? And of course, in some cases, we don't have any GSM connection, any internet network. In these cases, we need to cache all data set, all maps, all features inside of our laptop and prepare mission on the laptop as soon as we have very difficult projects. And of course, we need possibility to upload KML file, vector file, DTM, DEM, orthophoto in our mission planning software as soon as we made as soon as we work on the difficult tasks like three-dimensional mapping or mining site survey. And this software should work as well as with photogrammetry and as well as with LiDAR survey. And LiDAR survey has some additional features which can be implemented during the flight. And we need to make survey over the power lines, so we need to prepare linear mission. We need to survey area, to make area survey, to make oblique missions, and all these features, all these possibilities should be combined in one software. And of course, what we need, as soon as we use different type of cameras, for example, on Matrix 300 or Matrix 200, you can install Sony RX1 camera, Sony Alpha 7 camera. It's better that our user will have possibility to choose this payload from the software to prepare a mission and to get appropriate parameters for overlapping. What else? And for some reasons, for example, when you survey for the huge area and your starting point is far from area of survey, you need to fly as faster as possible to the starting point of the area survey. In this case, you need to know how to change the flight speed for the one part of trajectory, not for the whole trajectory, just to the one part. For example, from the starting point to the area of survey, and at the end of area survey, you just need to fly as much faster as possible to land a landing point. In this case, as you understand, there are a lot of requirements to tune up your mission planning. And as a result, we test a lot of software. To tell the truth, before we use Ground Station Pro, MapPilot, Pix4D, Drone Deploy, and so on. And finally, we found out that only one software should be installed definitely on our laptop. It is UgCS. And of course, firstly, we faced a lot of problems because we didn't understand the total workflow, and I would like to share it for you. Let's talk about simple photogrammetry mission. If you have any questions during my presentation, I will answer right now on this part and then move to another one part. Sabine, if you help me to
yes, we will check
ask
through...
me questions and I will reply.
Yes, we will do that when we have something.
Okay, I see some question about GNSS and IMU accuracy. So, it's very simple to answer you. The results of our survey provides free or 5 centimeter accuracy of derived three-dimensional point cloud. As a result, it means that our GNSS receiver provides approximately 2 or 3 centimeter accuracy of post-processing, and our IMU works on 200 or 300 Hertz rate, and its measure position between between measurement of GNSS receiver, which work on 10 Hertz up to 20 Hertz. As a result, we can post-process data, and we will achieve, we will get trajectory with 200 or 300 Hertz rate with accuracy within few centimeters. As a result, we will process data set and generate point cloud without any ground control points with accuracy of 3 or 5 centimeters from 70 or 150 meters altitude. For the next question, for photogrammetry, there is a requirement of overlapping the images. What about LiDAR? What is the recommended flight line overlap? It's a very good question, and I will answer during my presentation when we will talk about mission planning for LiDAR.
There is one question about can the LiDAR be attached?
About PixHub, I don't have any knowledge about PixHub, so I will leave it for you.
About attaching the drone to...
there is one question, could we provide information about PPK and RTK mode? It's very simple, you just visit our website and download sections. There are a lot of data processing tutorials, videos, and all information, including demo data sets with a raw data set, with ground control points to check the accuracy, and with step-by-step instruction how to process data. Can the LiDAR be attached fixed to an other than DJI drones? Of course. Why we choose DJI? The first issue, why we choose DJI drones, Matrix 200 and 300? Why? Because these drones have obstacle avoidance systems. In this case, you can fly safely in comparison with Matrix 600, because Matrix 600 doesn't have any obstacle avoidance system. In this case, but it can be installed on any drone, and it can be installed and removed easily. Alexander, could you show how to remove LiDAR from the drone?
Yes.
My friend Alexander, he will show how to remove the drone. Okay, just we need to remove antenna connector. We need to remove DJI, and our system is connected to DJI Xport or Skyport. And it's like a plug and play. You just click and you can walk. So it's very easy. Justin Cancel said that SLAM LiDAR is excellent. I would say that you should test SLAM LiDAR on the drone, and after that, I don't know how you can georeference data set with the SLAM technology, how to, we don't use any ground control points for data processing, and we don't use SLAM technology. It's real measurement in comparison with SLAM. What is the source of terrain data you are using for mission? Do you create custom or public data accurate enough? Okay, it's a very good question. And let me start my part of presentation, and I will show how to use additional data set, terrain data set in UgCS. Will be a portion where Maxim talk about the workflow of their LiDAR system from flight planning to mission acquisition. Yes, of course, definitely. You asked me all information which is prepared in the presentation, and we will talk about this later. And what is? Good day from Peru. Is better out ever that Phantom 4 Pro for photogrammetry? I would say that Phantom 4 Pro is the best drone for photogrammetry in terms of expenses and in terms of quality of the camera. Why? Because Phantom 4 Pro has a mechanical global shutter, and it provides very good accuracy, very stable. and you don't need to remove this rolling shutter distortion. In case of Autel or Mavic 2 Pro, in this case they use rolling shutter. In this case, you need to add additional correction, and all these steps of this correction is described. All steps are described in our blog, in our website, and I think if somebody help me, we will send some link for this dataset.
Definitely.
Of course, and finally, final question, and I will move on another one part of my presentation. Of course, we use figure of infinity to calibrate IMU, of course, and I will show you. Yes, and this is the last question is very good. Can be LiDAR used on unmanned surface vessel, robot, or boat, or can be installed on the drone? Yes. Why we choose? A lot of people work right now with LiVox sensors, and it's very good. And I think we will release LiDAR based on LiVox sensor within 1 or 2 months. And but what is the biggest advantage of our system? That it works on 360 degrees. In this case, you can install it on a drone like this one, or you can install in backpack. And I will show you backpack during my presentation. And you can install it on any vehicle. And I will and I think Evgeny will show it during our presentation as well. So how we use LiDAR how we use the same LiDAR, this one or this one, a different type of LiDAR. This one works on 200 meters altitude. This one works on 70 meters altitude. Sorry. Okay, and we can use this LiDAR system both on UAV, or we can use it in a backpack or in a car. Okay. Okay, I just answer your question. First of all, this one, it's a real system, and it works in any condition, and it works on any vehicle. So your question, what is the main advantage of using ultra LiDAR instead of solution of DJI based on LiVox sensor? I already answered this question, and what I would say, first of all, I would say that we should wait for DJI release of L1 system, and we should wait for real accuracy checking. I think what they announced that it is system just to get very fast point cloud for mapping and not for some disasters and so on. And they wrote accuracy between XY accuracy within 10 centimeters. They just indicated 10 centimeters accuracy from 50 meters altitude flight. I don't know if it is possible to use such accuracy in a surveying. We should check. Okay, let me continue. Okay, what else? So let's talk about simple photogrammetry mission. And I just select one project which we made for open pit survey. And as you can see, it was one question: from what source we receive terrain level? First of all, of course, we use UgCS, and UgCS download terrain level from available sources from internet. And as you can see, there is a flat terrain on an open pit site. And now I would like to show how to plan mission, photogrammetry mission over this area in order to follow real terrain, not the terrain which are available from internet. First of all, we should set up fly altitude for the drone, and we should set up action when drone will lose connection. I would choose continue mission in case of losing connection between the drone and the remote. And I would choose the trajectory type straight or safe. It means there are different type of trajectories. Straight, the drone will fly between points, like directly between 2 points, and safe drone will rise to the altitude of the second point and then reach the second point. And of course, you can choose any drone model which is available in UgCS. And I would say that I never saw so many drones which are supported by software. And next, what we need to do? We need to set up first waypoint, and for the first waypoint, we should set up flight altitude of this first point, and then we can set up flight speed between first point and the second point. In this case, if you plan mission far from your starting point, you can increase flight speed on this trajectory path. It will help you to save your time and power for real survey, not for flying with 4 meters per second to 1 kilometer to your area of survey. We can choose type of turning type. For example, for photogrammetry survey or for LiDAR survey, it's better to choose adaptive banking. Why? Because in this case, drone flies like a plane. And in this case, drone don't stop on the turning points and don't lose power to stop and start to increase speed. What else? Next step, I would select photogrammetry tool, just simple photogrammetry tool, and I will set up flight speed. I will set up a type of turning of the drone. I would set up ground resolution. GSD, but what I would say, this one thing which can be improved in UgCS, it's better to set up not only GSD, but it's better to set up flight altitude. Sometimes I don't know exactly which GSD I should reach, but I should know exact flight altitude in order to avoid obstacles. In this case, it's better to add possibility to add flight altitude for photogrammetry mission, as well as GSD, just to recalculate it due to different type of sensors. And next step, you should set up overlapping settings. And for photogrammetry, I would say that minimum 60% is required. Sometimes it is better to increase overlapping, especially for photogrammetry. For LiDAR survey, the situation is totally different. In this case, you can decrease overlapping up to 30% or less if you fly on a flat area, and all your data set will be correct. But with photogrammetry, you need to increase overlapping. Why? As more images you have over the one terrain, with using of the same points next as more images you have, is more accurate terrain model or three-dimensional model will be created. And what else? And of course, you can set up overall shooting just to fly outside of the area, and altitude mode agile or AMSA. There are some special settings for the camera, but I don't like to touch this question right now. And there is an agile tolerance parameter, and we will talk about it a little bit later. As you can see, we have a mining site, and UgCS just plan mission on like under the flat terrain. But in reality, we have excavation here, and we have some earthworks. So in this case, I would suggest to fly on high altitude, for example, 200 meters altitude or higher, just to make preliminary survey with photogrammetry and to generate a preliminary terrain model from photogrammetry. And after that, you can add this digital elevation model to UgCS. And if it is possible to create orthophoto, it's better to create orthophoto as well and to add to UgCS. It's very simple to do. Just add elevation. Just go to map layers, elevation, and then add your digital elevation model. And you can go to the map and you can add orthophoto as well. So it's very simple. But after that, you can plan mission more carefully, and you can follow terrain with a high precision. But what we can face? We will face that there will be more than 200 points, waypoints. Why? Because our DTM or DCM is very accurate and has a lot of changes in relief. In this case, I would suggest to use agile tolerance parameter. In this case, we just increase this parameter just to avoid changes, small changes in relief, and our drone will follow the terrain level, but without any coming up and coming down, and we will decrease number of waypoints as well. And as you know, all DJI systems, all DJI drones have restriction with 99 waypoints per mission. In this case, you can set up agile tolerance parameter just to increase or decrease number of waypoints as well. But be careful to avoid any high structures or any high buildings and so on. So you should prepare your flight carefully. And of course, we can add some actions for the camera and so on. And as soon as we set up everything in our office, usually we click offline map. We just cache all map layers in our laptop in order to avoid any problems in the field where there is no any internet connection or GSM network. In this case, it's better to make to cache your data set to your laptop. And what I would say that DJI, oh, not DJI, sorry, what I would say that UgCS increase productivity of the software and increase flexibility of the software. And right now you can upload your mission without connection to the drone, just connect your tablet or phone to the same Wi-Fi network, and after that you can upload your missions to your tablet as well. So it's very good option, and we were waiting for it for a long time. Okay, if you have any questions concerning this part, I will answer. If somebody will read these questions, for me it will be more easier to answer. Okay.
Maxim, for me, it's interesting what you will answer on the question why you choose UgCS over MapPilot. I don't have any experience with MapPilot.
Mm-hmm.
Can you answer?
Yes. So as I already said, we need to set up our fly mission carefully, and we need to make our missions more efficient in comparison with the common consumer software. In this case, for example, if we plan our mission and our starting point is far from our survey area, we can increase speed to the survey area. In this case, we save more time for real survey. On the other hand, UgCS provides a lot of functions to make to smooth trajectory, to fly faster over the same area, to set up all things together. For example, we can combine different type of missions in one flight. If we use three-dimensional mapping, and I will show you later in my presentation, we can combine a double grid mission with a oblique circle mission together in one flight, and we don't need to stop the drone, and we don't need to waste our flight time. And what else? I think I already answered the question with DTM and orthophoto, which can be uploaded on my laptop and can be all data set can be stored on my laptop. And I don't depend on any internet connection. And of course, using of my own terrain level or my own DTM provide me more stable flights and accuracy. What is the altitude limit of flying we are flying? In USA, it is Alexei, could you help me to read question, and what kind of question? If you find any interesting question, I will answer. Guys. Okay.
Yes, I will try to help.
Yes.
In Europe, altitude restriction by default is the same as in USA, 120 meters, 400 feet. So in some cases, yes, in case of high trees, yes, it will not be possible to stitch the map using Pix4D.
Yes, of course. In this case, in order to combine data, in order to create data, okay, in order to make air triangulation and to process data of the forest area, you need to increase overlapping or add additional additional flights like a double grid mission or some additional flights to increase number of overlapping. And we will discuss during our training for data processing, photogrammetry data processing, how to process data in the difficult conditions.
Yeah, one more. Okay, I can answer on a couple of questions. How the behavior of the sensor during turns? Does the drone automatically decreases the speed in U-turns? So here on the screenshot, on the screen of Maxim, you can see overshot and overshot speed. So you can add overshot. Here is 15 meters, and you can set decreased speed. For example, on survey lines, you can have 10 meters per second. On in overshot segments, which are outside of your survey area, you can have reduced speed. Initially, it was designed for magnetometers on ropes, but also useful for photogrammetry. Next question is, what coordinate system I need to use creating DTM? You need to use UgCS 84.
Yes, you can use UgCS 84 or any UTM projections. For example, in my example, I use just only UTM projection, and UgCS supports UTM as well. And if we are talking about how to reduce 300 waypoints to 99, you just increase. You just need to increase agile tolerance number just to decrease number of waypoints. It's simple. Yes, and final question, does it possible to calculate in UgCS proper path for LiDAR to achieve expected parameters for 20 or 30 overlap percent? I'm asking about LiDAR photogrammetry. Yes, and I will show you in my future part of presentation. Okay, if we don't have any questions, I will move on another one part of presentation. And right now, I just showed the result of survey of open pit area, and where we need to fly exactly on the terrain level in order to get the same resolution for the images, in order to get very good accuracy of for future volume calculation and so on. And I just show you how to use UgCS, how to cache your data set, how to plan mission, just simple mission. But next step, what I'm going to talk, and I would like to show you a real project. We just made results of real projects. We just made survey of the mining site area. And during this survey, we just use photogrammetry to create three-dimensional map and GIS layers of this mining site. And we use GPR system installed on Matrix 600 with UgCS as well, but it is another one story, and we can talk about it maybe during next presentation. But we achieved very good results to measure, to use GPR as well. And right now I would like to show you only one part of this work, when we create three-dimensional map and when we create GIS layer of mining site using using Mavic 2 Pro PPK. What does it mean, Mavic 2 Pro PPK? We just take original Mavic, and after that we install additional GNSS receiver on the top of the drone, and we connect with GNSS receiver precisely to DJI system to capture photo events. As a result, after data post-processing after flight, we will get very precise position of each photo, which can be used for photogrammetry data processing. And as we found out later, only this way provides possibility to remove rolling shutter distortion without using of ground control points. And as a result, Mavic, you can convert Mavic 2 Pro from a consumer drone to a professional survey system, and you will achieve 3 or 5 centimeter accuracy definitely. And you can add and you can read about a lot of tests, and you can talk with our clients, and they prove that this accuracy is easy to achieve. And our workflow in the field was: we install a base station, we prepare a fly mission, and in this area there was no any internet connection as well. And we make flight, and after that we post-process GNSS data, create very precise trajectory of the flight. After that we assign precise coordinates of the images to two images inside of ExactTech, and after that we process data set in Pix4D Mapper software and create three-dimensional models and maps. And it's just example of our survey area. We use MLEAD GNSS receiver as the base station, and people from a mining company was very surprised when we come to the area without a huge box of the equipment. We just use only a small GNSS receiver, and we just take this drone with us in a small backpack and nothing else. But we should make a survey over the 1,800 square meters, and the requirements of the agreement with the company. We had to deliver products within 2 weeks after the field works. What kind of product? Maps and orthophoto and three-dimensional model. And of course, we use UgCS to plan mission. And for one area we made 8 flights, and all these flights was prepared with UgCS. But before the flight, before the survey flight, we made the preliminary flight to make preliminary three-dimensional model. We uploaded to UgCS as soon as the terrain level on the mining site was changed a lot. And after that, we upload our own digital elevation model, orthophoto, prepare mission, and fly carefully without any problems over the terrain level. What next? What next? The next step, we capture data set from the drone. Here there is a SD card, and we just remove SD card to get Rhinex files, UBX files from the drone. We remove SD card from the drone to get photos, and with using of our TOPOSetter software, which provides possibility to post-process GNSS data and to make a connection between coordinates and images and geotag images in automatic mode. And it works in any coordinate system. You can add your own coordinate system. You can add your own elevation model like geoid and so on. And after post-processing, we receive a set of images with precise coordinates inside of ExactTech. We made photogrammetry processing in Pix4D Mapper, and as I already said, that Pix4D provides the best option for removing rolling shutter distortion. Why? Because camera of DJI Mavic has a rolling shutter. And after that, we achieved such accuracy, and accuracy was between 3 and 5 centimeters. And now customer check it with a GNSS receiver on the side. And after that, we create a three-dimensional model. And what I would say that Pix4D Mapper provides very good detailed three-dimensional model. And this model was captured from 90 meters altitude. And as you can see, we reconstruct all details of mining site, such as buildings, power lines, power poles, any hedges, walls, any construction sites. and it can be easily automatically classified in Pix4D Mapper. And as a result of data processing, as soon as we got very detailed point cloud, automatic point cloud classification was made in a high level. And this one example of three-dimensional model of power lines and power poles and any barriers, gates, and so on. And as a result, we classify terrain, we remove all vegetation, and we create contour lines. And after that, and this one is the example of details of three-dimensional point cloud generated by Pix4D Mapper. And after that, we vectorize point cloud to create break lines, to vectorize all buildings, walls, and so on. And as a result, and finally, on the basis of classification of point cloud, we create contour lines, and we create CAD data set for our customer. This one is the result of data processing. And on these slides, it looks very simple, but in reality, we to provide high quality data set, to provide accuracy, we should set up camera in an appropriate way. We should fly on a good altitude. We should follow terrain. We should make a survey. We should split all area. We should split huge area for the small parts to fly. And there was no any internet connection. And as a result, only UgCS can be used in these cases. I don't know any another one software which can provide such possibility. I think this one is the answer to your question: why we choose UgCS and why we don't use MapPilot. This one is just examples of CAD data set created with using of our equipment and UgCS software and Pix4D Mapper software. And now I'm going to move on another part of my presentation. It's a photogrammetry survey for three-dimensional mapping, for high realistic 3D modeling. In this case, I would like to show results of some real project made in one Middle East country, and it was very huge project for mapping. And for mapping, we just use only for 3D modeling. And for 3D modeling, we just use several Phantom 4 Pro upgraded by our PPK system. Why? Because we don't use any ground control points and we don't spend time for measuring them. We just use our PPK system to stitch all the images together. And we use special equipment installed on the car to make photos from the ground as well. And we use MLEAD base station for post-processing. And we just use UgCS to mission planning. First of all, we divide all area for different area of survey. It was 12 areas survey. We create camel file and upload it to UgCS. Then we have to make a lot of missions. First of all, we need to make a survey of a nadir mission, just to capture nadir images. It was a basis for future photogrammetry data processing. And we divide the area for 12 parts, and we add and we capture all 12 parts, and with the nadir images, and we set up all necessary parameters. After that, we have to add some additional images to create three-dimensional model of building structure and so on, some architectural parameters and so on. And in this case, there are two ways how to capture these images. First of all, you can fly with double grid mission with an angle of 45 degrees, to point the camera to 45 degrees. But you should turn your flight angle to 45 degrees in comparison with your nadir images. And you fly with but we arrange with flights for the area where there were a lot of buildings, and it's not possible to make oblique flights. It's just possible to make double grid mission, but with 45 degrees camera, and all this area was rotated. What else? Next, we plan oblique flights around buildings, which was were separate from other buildings, and we fly with oblique images, and we plan all flight missions with UgCS as well. And finally, we capture some photos from the car with our equipment. And as a result, we create a very detailed three-dimensional model as soon as we capture all buildings from different sides of view. And we combine different type of acquisition. As a result, we achieve 3 and 5 centimeter accuracy, and we captured 120,000 images. It's reality. So we captured 120,000 of images, and we post-process data, and we use special technology in our post-processing software, where we use batch processing. We just set up per one day. We process more than 10 flights from one drone. But we use 2 drones, so 20 flights should be post-processed, and we should process it automatically. And we create special batch processing option, which is available in our software, which is provided with together with our drones. And as a result, we create very detailed three-dimensional model. And additionally, with using of photogrammetry survey from the ground, we achieve very good detailed model under the coverages and on the ground, as well on the ground. And I would like to show you some example of this model. And it was not possible to achieve such model, to create such model with the common techniques, with the common software, with because we need to set up everything together, and all this survey was made within a few weeks. What else? Just example of this three-dimensional model, and we have special training for three-dimensional modeling if you need how to achieve very good accuracy and so on. So in this case, I finished my part of presentation of photogrammetry and how to use UgCS for real photogrammetry work in hard conditions. And if you have any questions right now, I can answer.
Yes, thank you, Maxim. We have already used 1 hour of the webinar, so we have to go a little bit quickly further.
Mm-hmm. Okay.
So a quick.
I think we have a lot of questions. Maybe after presentation we can answer it. But it's better to have a direct talking with the guys, because it's so many questions.
Of course.
Maybe we can expand some time of webinar. We just finished webinar right now, just asking, answering questions.
We are not so that we are finishing. Just we have to be a little bit.
But I can talk about LiDAR survey later.
No.
Okay. Okay. Let's continue. And now I'm going to talk about LiDAR survey. In general, as I already said, that before, when I don't use LiDAR, and before we invented our own LiDAR system, I supposed to buy one of LiDAR, but it was so expensive. The price of LiDAR was approximately $100,000 or $50,000 and so on. It is very expensive to install in the drone. And before, this LiDAR system was so heavy, so you can use only 6 motor drones like Matrix 600, but all these drones don't have any obstacle avoidance system. And it was not so safe to fly with these drones. After that, we started to design our solution for LiDAR survey. Right now, we designed LiDAR equipment, and we use very high precision IMU inside, and we use GNSS receiver inside, and SSD disk inside, and microcomputer inside. But the total weight of this system, for example, this one is less than 1 kilo. It's our LiDAR 100. And the weight is less than 1 kilo, and it can be installed on any DJI drone or any fixed wing drone. And after that, we created the same solution with Velodyne head, which works on 200 meters altitude, and it is TOPODRONE LiDAR 200 Ultra, and the weight of this system 1 kilo and 100 grams. So you can use it on the drone, and flight time of this drone is from 26 minutes up to 38 minutes, depends on the type of Matrix 200 or Matrix 300. And as you can see, it can be easily integrated with a DJI system, just like a plug and play. You just install it to original DJI connector. And you can connect it to original DJI camera, like X4S camera, like this one. Or you can use it with another one camera, install camera here. There is a special connector for the camera to install camera like Sony camera and so on. And it will capture photo events, everything, and it will manage the camera as well by LiDAR. What else? And of course, as soon as we use 360-degree view LiDAR system, it can be installed in the backpack, and it will provide very good accuracy as a backpack as well. And you can capture some data set, which you can capture some data which are not available from the air. You just walk on the street or install it in the backpack and sit in your car and so on. And I just leave these parameters of our LiDAR system, and you can read it and save it for future understanding. And as you can see, we use very high precision IMU, which and very high precision GNSS receiver, everything you need, and working altitude for LiDAR 100 is 70 meters, and you can fly easily with 70 meters altitude. So it's not forbidden to fly with such altitude in any country. And with LiDAR 200, you can fly within 150 up to 170 meters altitude, but working range in 200 meters. What else? And coverage area of this LiDAR is from 70 meters altitude is 150 meters wide of the area, and this one cover 250 meters as well, up to 300. And I would like to show you some example of our work when we provided training for our client. We install LiDAR system on the existing Matrix 200 RTK. I think RTK is useless for Matrix 200, but the client used this drone. He already had Matrix 210 drone RTK. We install our LiDAR on the drone and install additional GNSS receiver on the drone. And we use some ground control points to check the accuracy, and we install a base station. And after that, we prepare LiDAR flight mission. And let me talk about LiDAR flight mission in more details. First of all, we need to make a calibration flight like Infinity. And with UgCS, you can do it easily. Of course, you can fly Infinity in the air by your hands, but if you are not a professional pilot and you need to, all time you need to fly calibration flight, in this case, it's better to use predefined settings in UgCS and create this mission, this part of the mission. And after that, you can use two different tools for planning LiDAR survey. First tool, it's area scan. In this case, you know the coverage of each LiDAR. For example, we know the coverage of this type of LiDAR, it's 150 meters. In order to reach 30% overlapping between roads, I would suggest to set up 100 meters wide and so on. What else? We just set up all settings here. We set up altitude, we make a follow terrain mode, and we set up range between our flight passes, and nothing else. And we set up a flight speed. For LiDAR, for our smallest LiDAR, you can fly up to 100, You can fly with the speed up to 10 meters per second, and you will get a point cloud with density of 150 points per square meters. With this system at the same flight speed, you will achieve 350 points per square meters, but you can fly higher and you will cover a huger area. In this case, but if we fly with such parameters, we couldn't capture photos. We can capture photos, but we couldn't combine stitch all photos together, because for photogrammetry it's better to provide 60% overlapping, and if we are flying around above forest area, we need to increase overlapping. We need to decrease decrease distance between flight roads. In this case, we can use photogrammetry mission as well. And with photogrammetry mission, as you can see, we should fly much more. And this is very good question. If you ask me how we can increase efficiency, in this case, I would say you should fly with the LiDAR, separately with LiDAR, with 30% overlapping. And after that, you can use any our existing PPT drone and fly on a higher altitude with 60 or 80% overlapping, but with a higher altitude. In this case, you don't need to buy expensive camera to colorize point cloud. You just use our PPK system and use our LiDAR at the same time, but with different flights. And you know that UgCS provides possibility to fly at the same time as well. So you can fly easily with one person who will drive two drones at the same time. For example, one drone will fly on altitude 120 meters, like Mavic 2 Pro. It's just to capture photo, to colorize point cloud. And LiDAR will fly on 70 meters altitude at the same time. And this is it's the main advantage of UgCS as well. You can manage several flights at the same time, and you can stop one drone and fly with the second drone and so on. So in this case, I just show you how to plan photogrammetry mission, how to combine with photogrammetry, and what I would like to show you in real time right now, how to process LiDAR data. And as you remember, I already said that LiDAR data processing and generation of point clouds will take less than 20 minutes. And the longest time, it's GNSS data post-processing. It will take you up to 10 minutes to post-process GNSS data together with IMU. And I will skip this step. I just show you the result of data processing. And let's talk about LiDAR data processing shortly in a very short period. First of all, we need to post-process GNSS data together with IMU. For these features, you can use Inertial Explorer software, PostPack software, or TOPODRONE cloud-based software to post-process GNSS data together with IMU. After that, you need to generate point cloud. And point cloud generation will take 1 or 2 minutes per one flight. And after that, you need to make strip alignment and create a final three-dimensional point cloud. And you need to make some sorts of classification and future data processing. And I would like to show you within a few minutes. So first of all, we need to post-process GNSS data together with IMU to create very precise trajectory. And as you can see, we post-process the same trajectory of the same area. And you see some points with the numbers. It's a position of each photo which was captured by our GNSS receiver, which is installed inside of LiDAR. And as a result, we already achieve. We already compute precise trajectory of our drone, and we calculated precise position of each photo. And after that, we need to use TOPODRONE software. I will move to this software. This software called TOPOLIDAR. Just a moment, I will find it. Just a moment. Okay, so right now I will run TOPOLIDAR software. It's already, it was. already predefined. So after GNSS data post-processing, do you see my screen? Yes.
Yes.
After GNSS data processing, I have very precise trajectory, which just can be uploaded to the TOPOLIDAR software. It's a post trajectory, post file, and it's already uploaded here. Then I choose pickup file. It's a raw LiDAR data from a VLiDAR I had. Then I select a part of trajectory where I would like to create a point cloud like this one. After that, as soon as I select part of trajectory which I would like to use for point cloud creation, I just select output coordinate system, and we support any geoids, and we support any coordinate system as well. And after that, I just click start button. And system will compute LiDAR point cloud, and our software shows it in real time. And to tell the truth, it will take you a few minutes to generate point cloud from one flight. It's totally unbelievable. If we compare a point cloud with a photogrammetry, it will take you, I think, to generate the same point cloud with photogrammetry, it will take you a few hours or 10 hours or one night to generate point cloud. But with the LiDAR equipment, you just achieve with the same data set. You will get the same data set within 1 or 2 minutes. And after point cloud generation, we will look at the time. Okay. As soon as we generated point cloud, we need to open this point cloud in additional software like LiDAR 360, like TerraScan, to make strip alignment. And it is very simple, and I would like to show you. Just wait while our software generate point cloud. And we will get the result. So right now our point cloud was generated, and it took us 1 minute and 45 seconds. And now we will upload it to LiDAR 360 software. And we upload this point cloud. Just point cloud which was generated. The next step, we should open strip alignment interface, and we should upload the trajectory first. And our software generate trajectory in a local coordinate system as well. And as soon as we upload trajectory, we should select appropriate fields. And click apply, and our trajectory is shown on the map. As you remember, we remove all parts of infinity of trajectory. And finally, we should split this trajectory to separate flights. And we will create separate flight and we will create a separate point cloud. I will ask to open the window because it's too. And software will split point cloud to separate flights. And I think it is the longest part of our data processing right now, because okay, we just split our point cloud to separate flights, and we can colorize them on the basis of color of trajectory. And finally, what we should do, we should calculate delta roll and pitch and heading angles due to we can talk about it later because of the timing. And finally, we calculate delta angles, and our data set is ready. And we apply this correction to data set. And finally, after applying correction of the angles for each flight, we can merge all flights together, and after that we can check the accuracy. I will skip this step of merging. I already have a merged point cloud, but I would like to save time for Evgeny, and I will open merged point cloud. And this one, it's a point cloud from a LiDAR survey. And I can colorize it by elevation. And now you see that we fly over the hard to reach area with a lot of trees, and we can easily classify terrain here. What we can do, we just click classify, and we just spend a few minutes to get classified terrain level. And of course, we can check the accuracy with ground control points, which were measured with our client. We measure all ground control points together. But just let's spend few minutes to look how fast we can classify terrain level with a LiDAR point cloud. And this LiDAR point cloud was created within few minutes. It's amazing. So you can achieve, you can get your results in the field at the same time. So you can provide your customers with a precise terrain level with the same name after the flight. And this one, it's a terrain level. And let's create control lines.
Maybe whilst processing, we have one question. Why?
And we created the control lines, and let's have a look how accurate these control lines are. And it's amazing. And it's not possible to achieve with the photogrammetry at all in such deep vegetation area. And what else? What else? And of course, we can check the accuracy as well. I just load some ground control points. As I already said, that with ground control points were measured together with our client, and you can talk with our client as well, that it is measured in appropriate way. And let's check the accuracy of ground control points. I will increase the size. And we measure some ground control points on the road and so on. And we try to measure it in a forest area, but we couldn't achieve fixed solution at all. We have some points, but they were not so accurate. Let's check the accuracy. With one point, we just create a slice of a point cloud. And as you can see, and let's measure the accuracy of this point up to point cloud. It's just 1 or 3 centimeters accuracy, definitely. And if we measure all points, you can download this raw data set with the GCPs, with everything you need from our website, and you can check and you can process your data set. And this one, it's a ground control points. It's the same area, and you see that it is has the same accuracy within 1 or 2 or 3 centimeters. So what I would say that, how we can compare photogrammetry and LiDAR? I think photogrammetry is an affordable solution, but when you make a survey with photogrammetry, you should take into account a lot of settings like lighting condition, like overlapping, like level of noises. LiDAR is more simple to process, is faster to process, but you can combine photogrammetry and LiDAR when you would like to get a colorized point cloud. In this case, you need to add some part of photogrammetry just to align images, and after then you can colorize your point cloud. And I would like to show you the example of colorized point cloud, which was created from the same flight with RGB camera installed on Matrix 200. We use X4S Matrix 200 camera combined with LiDAR. So if you use your own existing Matrix 200 or Matrix 300 or Matrix 210 RTK, you can easily install LiDAR system like this one, and you can use your existing camera to colorize point cloud, but you need to modify camera to capture photo events to get very precise position of each photo. In this case, I think your productivity will, your efficiency will be increased in 10 times or more. And if you have any question, I can answer, or we can we will allow to Evgeny to show his results. What do you think, Alexey?
I think let Evgeny start, and you can write answers in Q&A window.
Okay. I will have a small rest, and then I will write answers. Okay.
Okay. So thank you, Maxim. I should say that I never saw such high resolution results of 3D reconstruction from photogrammetry. Never. And your results with LiDAR is very impressive.
Thank you, and I hope our users will prove the same quality and accuracy as well. Okay, thank you, and I will leave you, and I will answer your questions.
Yeah, thank you, Maxim.
So probably you see my screen at the moment. I would
It's
like
connecting.
yeah.
Yes,
I
connected.
would like to introduce myself. So I'm Evgeny Lopatin. I'm working as a researcher at Natural Resources Institute Finland, and we were very much interested to see what kind of how the different tools can be used at the moment for tree-wise forest management inventory. And today I would like to cover like two topics, this close range photogrammetry, which is from my point of view only possible if you use UgCS. And then I would like to cover a little bit on laser scanning to continue the talk of Maxim to show like how the laser scanning data could be applied in practice and what kind of results we get out of it. I'm doing research, and almost 14 years I'm flying drones, and I'm a forest owner in Finland, so I'm managing own forests, and also I do a lot of research nowadays on digital technologies for practical forest management. We also use drones for forest fires forecasting. We also use drones for early detection of pests and diseases. Nowadays, bark beetle is a huge issue, and we are. But today I would like to talk more about practical and technical applications. In our research, we developed an approach for tree-wise forest management inventory, and this approach is based on the photogrammetry. So the idea is very simple. Like if you take a normal drone, you could of course build, for example, three-dimensional model, but then you need a lot of ground control points, which is not feasible in forest conditions. And that's why we started to use TOPODRONE solutions. So it means we could, for example, get precise coordinates of the pictures. And then through our data processing platform, we can recalculate into 3D models, and then we could get crowns. And then for each crown of the tree, we can identify the species, and then measure, for example, tree height, and then evaluate the diameter. So this is our general workflow which we developed, and we have a completely automated system which can be used for large area mapping. For example, we recently completed projects where we mapped hundreds of thousands hectares of big areas in different parts of the world. And in our research, we also wanted to test different consumer drones, so-called like drones, what you could get from the market for such kind of applications. And one of the results is that if you use this consumer drone, your accuracy of your height measurements of your object, especially if you start to model, for example, do three-dimensional models, will be relatively low. So inside the model, the accuracy will be good, but absolute accuracy of the result will be not so good. So you could get errors up to 6 meters, for example, in height estimation. So what we did, we used a solution developed by TOPODRONE, here one of the oldest version. So by adding this GNSS device, you could increase accuracy of your georeferencing to very high level. And then this could be used for example, for tree-wise forest management inventory. And in my research, I was once faced a situation that, okay, you do know how to inventory the trees, you do know how to inventory the forests, but are there any opportunities to inventory the, for example, young forest plantations? In case of Finland, if you harvested the forest, then you need to plant new forest, you need to regenerate the forests, and you need to plant new trees. And of course, not all the trees will survive. And it means kind of practically, we are investing about €0.50 per tree. And if you think about like planting norm, the value of this investment is about €1,170 per hectare. And to inventory those trees, you could use this kind of rubber boots method. So you can wear rubber boots and then go and count, which is not very efficient. And the most problem with this traditional kind of rubber boots method, you don't have coordinates, or it would take a lot of time to measure those. And for us, for our research, it was very important to identify the location of the seedlings and then also classify the health status of the seedling. If the seedling dead, for example, we can plant a new one. And here, to solve this issue, I had a lot of challenges, like how I can fly in partly open area. So when, for example, you fly in a completely open area, like Maxim presented today with the carrier, it's relatively easy. But what if you have already some trees in between, and how to fly in such kind of solutions? And if my first idea was, okay, let's use, for example, this Mavic, and let's rely on its obstacle avoidance sensors. I made one flight, it was successful. On the second flight, Mavic crashed. it was simply was not able, the obstacle avoider sensor was not able to solve a solution to where to fly if it was between couple of trees. So it was very funny story, like the drone found the area, it was surrounding by 3 different trees, and this very fascinated kind of hardware was not able to make a decision to which area, to which direction to go. And then the drone was crushed. So I started to think like how to solve it, and thanks to UgCS, we have now opportunity to have like 2-step inventory process. So the first stage, you could get like so-called a big picture to map the obstacles, and then you could use the UgCS features to do this so-called smart flight. And in my case, I used, for example, Mavic 2 Pro to fly very close to up to 5-meter altitude for photogrammetrical purposes. And how to do it? You could get, for example, this after the first flight. You can see the we have the digital surface model as the input data into it, and I just zoom into it. You see very clearly. So the big standing trees, they can be used as an obstacle, and using UgCS, you can guarantee that the drone will not go into the forest. It will be not crash into the forest. But moreover, this is not a flat surface. There is, of course, some changes in elevation. In this particular site, the elevation difference was about 35-meter altitude. So to cover completely the area, it's almost impossible, to do this kind of easy flight if you, for example, use Pix4D or MapPilot or other software. So I first used, for example, Pix4D, and I was not happy with the results because I was not able to vary the flying altitude. And in my case, in case of close range photogrammetry, in order to be able to see those very small seedlings, this is the example. So the height of the seedling is only 14 centimeters. The only way to see it is to fly it from the altitude of 5 meters. And here on this slide, you can see, we produced this map flying this from 120 meters. And then we had to develop the method, we established intensive research plots. So then we repeated by flying those research plots at the altitude of 5 meters. So using UgCS, it is possible to make 5-meter flights. Why we wanted to have 5-meter flights? Look at this picture. This is a picture from a drone. So if you start to interpret here, there is not only seedling, but there are all many other objects. Like you could have grasses, you could have other trees, etc. So the only way to automate the data processing is to process this data not as a two-dimensional data, just mosaic, but the only way you need to reconstruct the photogrammetric point cloud. And for this purpose, you need to fly in double grid on very low altitude to be able to derive really detailed fine scale photogrammetric model. So at the moment we from 5-meter altitude, you can build a point cloud with distance between the points, which is around 5 millimeter. So if you think about like resolution, so it's like 5 millimeter per pixel of the data, which is very promising. And I think there are many other applications, especially in agriculture. For me, it was important to see small seedlings and to be able to map the small seedlings. So here, this approach, and I see very clear advantage of using the software to be able to fly at very low altitudes. Then if you use a photogrammetry anyway, there are challenges. For example, one of the challenges of this method that of course it is possible, but in terms of productivity, you really need to do a lot of flights and a lot of data collection. So we started to look, okay, what could be any benefit of using LiDAR? And we invited TOPODRONE to make a test, and we wanted to test their equipment, and we wanted to see how it will work. What if we will be flying not in springtime or in summertime, but what if we will fly during the night, and what we could get out of it. So we made this test in December. So we use UgCS software to plan the flight. Then we installed the TOPODRONE LiDAR on our equipment with GNSS receiver. It was one of the questions in your chat box, what kind of GNSS receiver, GNSS equipment you are using for the base station. So we use this latest MLEAD device with 2 frequencies GNSS receiver, which works very well in our conditions. And then we made it, first we fly this area with a drone, and then I suggested, okay, let's put this LiDAR on my backpack and let's drive a quiet bike over the forest and see what kind of accuracy we could get. So first to the results of aerial laser scanning. From matrix 210, from 70-meter altitude, you could get very accurate point cloud, because here I think it's one of the additional value what you could get also from UgCS, because if you know the topography of your survey, then you don't need to spend your energy to extra overlap or to extra movements in order to compensate your flights. So I think here the UgCS allows you to save your flight time. And if you're saving your flight time, it means you can get bigger coverage of the areas, and you increase efficiency of your work. So as a result, we've got this point cloud from LiDAR. Then we were able to classify the points as Maxim presented very easily. We were able to build super detailed digital elevation model. But then for us, it was very important also to evaluate the trees. So what we did, we normalized point cloud by digital elevation model. And immediately in a field, we were able to get the result. You can see here that red are commercially valuable trees, green are young stands, and blue is presented by ground. So if you think about point density, how much you could get from this TOPODRONE LiDAR version 100 with matrix 207 from 70-meter altitude, average point density was about, let's say, 150 points per square meter. Of course, you can see here on the slide that this density was higher below the under the drone. And if you can see from this data, from this density picture, you can see the flying patterns. So, but you can vary it quite a lot and then configure it properly to achieve the needed density. And what you could get out of it is this point cloud can be automatically classified very quickly into the trees. So you can see here, every single tree is identified and colored by different color. And you measure the tree height with very high accuracy. So we are able to measure tree height here with accuracy from 3 to 5 centimeters. We also can calculate the crown projection area, crown diameter. But unfortunately, we do not always see in this point cloud the tree diameter. And in traditional forest inventory, you need still to go to forest, establish sample plots to be able to measure, kind of extrapolate or to recalculate your results using tree height, using species, using crown diameter into the tree diameter. And then I suggested, okay, let's use this technology further. And what we did, we used exactly the same LiDAR. We installed it into the quad bike, and then we started to drive with Maxim quad bike over this area and walk around. So we were able to collect a huge number of points from 360 degrees, and average distance from the scanner was about 70 meters, from 70 to 100 meters. And of course, we had some noise in the data, but this noise can be easily removed by the filtering the distance. For example, sources of noise were quad bike in the point cloud, shoulders, heads, or colleague, or something like this. But by for example, removing points which are very close to you, you can really reduce amount of this noise. And then we could also play with the angles, because if you properly select the angles, you can crystallize the point cloud. And if let's look again, what was the density of the points, what we were able to get from quad bike. So on average, we were able to get something up to 500 points on average per square meter. In some areas where we moved slowly, the number of points was higher. On areas where we moved faster, the number of points was lower. And this information is extremely useful, because if you fly your drone, and then if you go with quad bike, you could get such kind of dense point cloud with such kind of level details that you can measure automatically the crown tree diameter. You don't need to go to the field. You don't need to take caliper. You can just measure a lot of features directly from the point cloud. And imagine here we were driving the quad bike about half an hour, and in half an hour we automatically measured 4,169 trees. If I would imagine the same work done traditionally with caliper, I would spend 70 days, 8 hours per day working, so which is very, very hard, and it would require a lot of resources. So this is, I think, very big opportunity. So in case of like laser scanning in Finland, it's not new. In Finland, we started to use laser scanning data already for many decades. Public data is available, so you can go to internet and download even raw data and process data. So the first forest inventory program at the moment in country, the density was 1 point per square meter. The new program, which is now going, it's 5 points per square meter. This drone, with UgCS software, you are able to derive a point cloud from the air from 150 points per square meter. If you add something like quad bike, you could get almost 500 points per square meter. So if you think about forest resource assessment, using a LiDAR, it's practically like a zoom on your forest structure. And I think it's a future, and combination of those two methods for data collection is allowing to get really additional value from data fusion. You can change drone flying parameters to achieve the terrestrial density, and you can measure the angles from the air. For what for this data could be used? So you can, for example, identify quite many parameters which would improve the, for example, trees valuation, such as crows bait height, straightness of the stem. For example, you can identify immediately wrong trees or wrong stems. You can measure indirectly age of the trees. You could evaluate wood quality, wood assortments, and get precise valuation of the stands. And I think the opportunities what UgCS is offering right now is the opportunity to run precision forestry and to do more precise inventories. But of course, with laser scanning, it is possible also to do inventories during winter time and during a night time. Nowadays, laser scanners are everywhere. So, for example, if you buy a new iPhone, you could get even laser scanner inside. But here, in many laser scanners, those are based on so-called SLAM technology. And I think the advantage of the equipment what is offered by TOPODRONE is you are not using SLAM. You are able to reference your point cloud. For example, imagine you can take your iPhone and you could get very, very nice laser scan of your room. But what if you go to field? Then you're in troubles because you need to georeference your scan, and which is impossible without ground control points. And so that's why I think the opportunities which are offered for UgCS software and TOPODRONE laser scanners are really great. And at this stage, I would be very happy to answer any questions if there are some in our discussion today.
Thank you, Evgeny. It's very interesting always to see real cases, real applications. So yes, it's like great. Maxim, had you the opportunity to choose some more questions which we could ask?
And I think we can answer together with Evgeny all of his questions. And considering if we are talking about unanswered questions, about drone harmony, I'm not sure. I think UgCS have some advantages as well. Sabine, could you read some questions and I will answer them? What do you think is which are important? I will answer.
So yes, here we have which GNSS base station do you use?
As I already said, you can use any GNSS survey grade GNSS receiver as a base station, but I would suggest to use ReachRS2. It's the most affordable GNSS receiver at the market right now, and for the base station, it's the best option.
Yeah, there was a question also on can we use QGIS and Esri to import and analyze LiDAR data? Of course, if your point cloud is processed, then you can do quite a lot of things with it. But for example, you need to have some kind of algorithms, for example, for really accurate trees identification and mapping. And this is what we are developing at the moment.
And another one question was, I don't know what we have. Did you use a gimbal or pole? Concerning what? I don't understand the question. Gimbal or pole for what? I think all questions will already answer all questions. If any question arises, I will be glad to answer.
Yes, so of course, everybody can, so I now I'm displaying the contacts of UgCS, of our company, and also to TOPODRONE. So just if you have some further questions, just please reach out to Maxim and also to our support, so we will provide more detailed tech specs on the LiDAR which are used. And there was also a question, which is the main difference between the LiDAR 200 and 400, which you presented.
We have two systems, LiDAR 100 and LiDAR 200. The difference in the working range. First of all, the lightest one, which has a weight less than 1 kilo, it can work on 70 meters, 70 meters altitude, 70 meters. And the biggest one can work on 150 or 170 meters altitude. I would suggest that for the most part of work, this one it's enough. And the weight of the system is very low. And you can use it in a backpack or in the drone. So I would say, and it is very affordable and very accurate and very stable results. And I saw some question to Evgeny about software.
Yeah, the software, and then before I jump to software, there was a question about if this data could be used for forest management, such as height, lie, vegetation types. Exactly. Both data sets, so photogrammetry data sets and LiDAR data sets, could be used for such kind of measurements. But the key difference is, like the key problem of photogrammetry is that you cannot see through the trees. You don't have points under the tree cover. And that's why I would say, let's say with photogrammetry, my experience, usually you could get big trees. So trees with more than, let's say, 10 centimeter in diameter, trees more than 10 meters. You would get them accurately. All the small trees, maybe yes, maybe no, depends on the trees, depends on the condition. With LiDAR, the advantage is that you can really see everything. So LiDAR is giving you a possibility to see some features which you are not able to see under using traditional methods. For example, you can see with LiDAR seedlings which are growing under the tree canopy. And the biggest difference with LiDAR and photogrammetry that in LiDAR the number of points is so huge, so that it could, if you send, let's say, billions of points, some of the points will penetrate, not all. Maybe some of the points will reach on, but due to the huge number of points, the probability to get data and the valuable information is higher comparing with photogrammetry. The software, we are developing the software in our research. So we have our own prototypes at the moment. And if you are interested, we can process your data, or we could give a hint how to process the data. So feel free to contact. At the moment, I think it's very interesting and promising direction. And we would be very happy to handle your data or give you advice how to process the data. You have also my email address in the presentation, and I would be very happy to help you.
Yes, thank you very much. So, wow, what a great presentation. So I think the most questions are answered during and also in written. So as I said, also we will publish the presentation, the recording together with the answers to these questions. And yes, for any further communication with any of our teams. So yes, we have receiving also thanks from the participants. Thank you for the patience for this long webinar. So Okay, I
Thank you.
think, yeah.
Sabine, thank you for opportunity to share our experience, and we will. We are usually we are focused to talk with surveyors to share experience and to provide them enough knowledge to increase their efficiency and accuracy.
Thank you.
Yes,
Thank you for a lot of questions, I think.
Yeah, thank you for excellent software. We really love it, and thank you for a opportunity to present how we could use it in practice.
Yes, great. That's really awesome. So we collect also from the questions and from your feedback what should be improved, and yes. So yeah, Maxim, Evgeny, thank you all for participating, and let's meet in another event. So
Bye-bye.
have a great
Thank you.
day,
Yeah.
evening, night. Yes. Bye bye.
Bye bye.